In this section, we're going to take a look at independent events, and here's the definition. Two or more events are independent from each other if the probability of occurrence or non-occurrence of any one of them is not affected in any way by the occurrence or non-occurrence of any other. We can do an example to make that clearer. So suppose you toss a die twice, and A is going to be the event that a 4 pops up on the second toss and a 2 appears on the first toss. Now, I'm going to say that getting a 2 or getting a 4 on the second toss has... Suppose you toss a die twice. A will be the event that a 4 appears on the second toss, and B is the event 2 appears on the first toss. Now, I'm going to claim that getting a 4 on the second toss is in no way affected by getting a 2 on the first toss. I'm going to say that these two events are independent. I would say that the probability of A is still 1 out of 6, right? There's 6 possible outcomes when you toss a die, 1, 2, 3, 4, 5, 6, and there's only one way to get a 4. So essentially I'm saying this is, if I put it in conditional probability, what's the probability of A given B? All right, well, this is the probability that A occurs given B occurs. And I'm asking, what is the probability of getting a 4 on the second toss? It's like this. What's the probability of a 4 on the second toss given that you got a 2 on the first toss? Well, that's just equal to the probability of A, right? This B has nothing to do with it. B in no way affects the probability of A. So these two events, A and B, are independent. Now, we had a formula in the last section for the probability that A and B both occur. And that formula was this: the probability that A occurs given B occurs times the probability that B occurs. That was our formula that we developed in the last unit. Now, if A and B are independent, if A and B are independent, sort of, then we can write it like this. What's the probability that A and B occurs? It's the probability. Now, A and B are independent. So what do you know about this? What's the probability of A given B? Well, if B has no effect on the probability of A, this is just the probability of A. So it's just the probability of A times the probability of B. And sometimes this is referred to as the multiplication principle. So what it says is that if you know that two events are independent, you can just multiply their individual probabilities together. Here's another numerical example. Suppose that the probability of A is 0.6, probability of B is 0.8, and you know that A and B are independent. Then we know this. What's the probability that both A and B occur? Well, since they're independent, I can multiply those individual probabilities together, 0.6 times 0.4, getting 0.24. So what it says is that if there's a 60% chance that A occurs, an 80% chance that B occurs, what's the probability that both of them occur? There's a 24% chance that both of them will occur. Here's another example. Toss a coin twice. What's the probability of getting a head on the first toss? Okay, first toss. What's the probability of getting a head on the first toss and a head on the second toss? So now when you think about it, does it seem reasonable that these two tosses are independent? Whatever happens on the first toss in no way influences what happens on the second toss. So these two events are independent. So I can write this as the probability of a head on the first times the probability of a head on the second. Head on the first, 1/2. Head on the second, 1/2. Probability of getting a head on the first and the second is 1/4. Here's another example. Suppose you toss a die 3 times. What is the probability of getting a 2 on the first toss and a 3 on the second toss and a 4 on the third toss? Well, I'm going to claim that these tosses are independent, right? What you get on the second toss is not influenced at all by what happened on the first toss. So I think these are independent, and so I'm going to write that this is equal to the probability of getting a 2 on the first times the probability of a 3 on the second times the probability of a 4 on the third, and this is going to be, what's the probability of a 2 on the first? 1 out of 6. 3 on the second, 1 out of 6. 4 on the third, 1 out of 6. And this comes out to 1 out of 216. So what that means is this. If you just made an interpretation, if you toss a die 3 times, what's the probability of actually getting a 2, then a 3, then a 4? If you toss this die 216 times, you would probably see, we would expect to see this 1 time. Let's actually write an interpretation for that. What we really want to do is get a feel for what these numbers mean. It's not that we're going to be computing these very often in statistics, but we'd like to know what they mean. So here's what it means. We expect to see this event, 2, 3, 4, 1 time in 216 tosses. So you toss a die 3 times. You do that 216 times, right? What do? You toss, toss, toss. 216 times. We expect to see this sequence, 2, 3, 4, 1 time out of those 216 tosses. Here's another example. Suppose you take a standard deck of 52 cards, and what we want to do is find the probability of getting a 2 of spades on the first draw and an 8 of spades on the second draw. Now, here's what we have. There are 13 spades in the standard deck, 13 clubs, 13 diamonds, and 13 hearts. 52 cards altogether. 13 of each suit. Now part A is asking us, what is the probability of getting a 2 of spades on the first draw and an 8 of diamonds on the second draw? So you see an and, right? You see an and you ask yourself, are these 2 events independent? Well, I'm going to claim they are, because what are we doing here? We're selecting these cards with replacement. That means you pick a card, and then you put it back in. So there's still 52 cards. Then you choose the second card. So I'm going to say that they are independent. Whenever I see that and sign, I ask that question, are they independent? So they are. So I'm looking at this. What's the probability of getting a 2 of spades on the first draw times the probability of an 8 of diamonds on the second draw? Well, there's only 1 2 of spades, so this is going to be 1 out of 52. Only 1 8 of diamonds, so this is going to be 1 out of 52. And that turns out to be, 1 times 1 is 1, 52 times 52 is 2704, according to my calculator. Now, that means that if we actually did this, right, in sequence, draw 2 cards, and if we did that 2704 times, we would see a 2 of spades on the first and an 8 of diamonds on the second, 1 time out of 2704 trials. Pretty unlikely event. And part B, let's do this. What's the probability of getting this event here? Okay, without replacement, I still want this same thing, right? So I'm looking for this. What is the probability of a 2 of spades on the first draw and an 8 of diamonds on the second draw if the drawing is without replacement? So I still see this and sign. So I always ask that question. When I see that and sign, are these two events independent? And the answer here is no, because if you draw without replacement, you make that first draw and you leave that card out, you've changed the sample space. There's now only 51 cards left. So what I'm going to write here is, what is the probability of getting an 8 of diamonds on the second draw, given that I got a 2 of spades on the first draw, times the probability of a 2 of spades on the first draw. So what's the probability of getting what's the probability of getting an 8 of diamonds on the second draw? Well, there's only 51 cards now, right? Because you took the first draw out, and there's only one 8 of diamonds. All right, so that's 1 out of 51. And what's the probability of getting a 2 of spades on the first? Well, there's 1 2 of spades, but there's 52 cards. And if you multiply those together, 1 times 1 is 1. 51 times 52 is 2652. So the probability of seeing a 2 of spades on the first and then 8 on the second, that's going to happen one time out of 2,652 draws. So just to push things a little further, what would you say to somebody you don't know who comes up to you and says, I just did this experiment where I picked 2 cards in succession without replacement, and I got a 2 of spades on the first draw, an 8 of diamonds on the second draw, and that happened to me 50 times. What would you think? Would you reject that claim? Or do you think you'd buy into it? Well, that's why we want to know some probability, because if you know the probability, that's really, you're expecting it to happen once. And this person's telling you it happened 50 times. Yeah, I don't think I'd go with that. I would reject that claim.